When we are graphing logarithms, the main thing that we need to remember is that a logarithm is the inverse of an exponential function. So if we graph f of x equals 2 to the x, and we make an xy chart, just going to do this over here. So we had f of x equals 2 to the x. Now, from previous classes, we know that we just need to make an xy chart. So if we make an xy chart, we want to use negatives, positives, and 0 for x. So we can use negative 2, negative 1, 0, 1, and 2. And then if we plug them in, we're going to get resulting y's. So 2 to the negative 2 is going to be 1/4. 2 to the negative 1 is going to be 1/2. 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. So we have these points. So if I go to graph these, so negative 2, 1, negative 1, 0, 1, 1, 2, and 2, 4. Okay, we have an exponential graph that we have seen before. And we know that the domain and the range of these from the other class, the domain is going to be all real numbers, and we know that the range is going to be y is greater than 0. And we also know that this has a horizontal asymptote at y equals 0. So that's just kind of recapping what we had done before. So now we have g of x equals log base 2 of x. And since g of x is the inverse of f of x, we're going to just plot the inverse. So here, when I do my inverses, g of x equals log base 2 of x. I'm just flipping my x's and my y's. So instead of my x being negative 2, my x is going to be 1/4. Instead of y being 1/4, y is negative 2. So all of my x's and y's are flipping. So now I have 1/2 negative 1, I have 1, 0, I have 2, 1, and I have 4, 2. So now if I go to plot these, I'm plotting 1/4 negative 2. That's about here. I'm plotting 1/2 negative 1, which is here. I'm plotting 1, 0, 2, 1, and 4, 2. So if we look at this graph, it looks similar to f of x equals 2 to the x, but it's reflected over the line y equals x. So there's, some line here, y equals x. And if I were to draw this on paper and fold it along that dotted line I just drew, they should match up. So what we know about exponential functions will just be the reversed or the inverse of the logarithmic function. So instead of the domain being all real numbers, the domain is going to be x is greater than 0. So the domain kind of becomes what the range was. And it's x instead of y since it's the domain and not the range. And now the range is going to be all real numbers. So it's the flipped version. And then instead of having a horizontal asymptote, we have a vertical asymptote at x equals 0. So it's the same idea. There's still like a boundary line that this graph can't cross, but now because it's reflected, everything's reversed. So let's look at another examples. So if you know what the graph of y equals log of x looks like, you can use transformations to help you graph other functions. So in this chart, there's vertical translations. So if something's being added outside of the log, that's moving it up. If something's being subtracted outside of the log, it's moving it down. If you have something inside the parentheses with the x, and it's a minus sign, it's moving it to the right. And if you have something inside the parentheses with the x that's a positive, it's moving it to the left. So as long as we can create the original log function, you can just move each point up, down, left, or right, wherever you need to move it to. So first thing we want to do is we want to figure out what this is going to look like. So f of x equals log of x minus 1. Since there's no base, the base is a 10. So before we even start graphing the log function, let's graph the exponential, or at least write our xy chart for that. So if we did 10 to the x, since the base is 10, if I make an xy chart here, I'm going to use my -2, -1, 0, 1, 2. So this would become 1 over 100. This would be 1/10. This would be 1, 10, and 100. So that would be for the exponential. Since we know that the log is the inverse, we're just switching our x's and y's. So we have 1 over 100, -2. We have 1 over 10, -1. We have, 1, 0. And then we have 10, 1. And we have 100, 2. So that's typically what we're going to graph. But because we have this x minus 1 inside, this really means that it's moving to the right 1. So if I graphed 1 over 100, -2, so that's going to be about here. And I'm moving that 1 to the right. So that's going to become here. Okay, so I'm going to erase my red. So now I'm going to graph 1 over 10, -1. So 1 over 10, -1 would be like here. And then I'm moving it 1 to the right. So it becomes here. These are hard to draw since they're very small. So then I have 1, 0. So 1, 0 would be here, but I'm moving it 1 to the right. So it's going to move to 2, 0. And then I have 10, 1. So typically that would be here, but I'm really going to move it 1 over. I'm not going to graph the other one since it's crazy. Okay, so there's my graph. And now, because I shifted it, my domain and my range and my vertical asymptote are going to shift. So my domain usually, in the other example when there was no moving, in the log base 2 of x, when there was no shifting left or right or up or down, the domain was x is greater than 0. But now I moved it to the right, so the domain is going to be x is greater than 1. And then my range is still going to be all real numbers. And then my vertical asymptote is going to be x equals 1. So the vertical asymptote and the domain are the same number. Okay, if we look at the second example, we have a 2 outside. So this means that it's moving up 2. So I'm just going to use the same xy chart that I have because the log still has a base of 10. So normally, we're going to use this one here. I would have 1 over 100, -2. So it'd be about here. But now I'm moving that point up 2. So that point's going to become here. And next point would be 1/10, -1. And now I'm moving that up 2. Oops. So that becomes about that point. And then I have 1, 0. So 1, 0 would be here. But now I'm moving it up 2. So it's here. And then I have 10, 1, which would be here. But now I'm moving it up 2. So it's here. So then we're just going to fill this in. So in this case, if it didn't move left and right, the domain is going to still be greater than 0. So only when it moves left or right do we have to change the domain. So x is going to be greater than 0. The range is going to be all real numbers. And the vertical asymptote is going to be x equals 0.